Let's solve for this integration by substitution here. So you have integral of exponential sine x times cosine x dx, okay? So the first thing we got to look at is, does it look like something like this format here, where we have integral of u prime of x times u of x dx, or way around u of x times u prime of x dx. So that means if we look at this one, for example, cosine x, we look at this one, sine x, of the problem integral exponential sine x times cosine x dx, what do we see? We see that the derivative of sine x is what? Is cosine x. We see that, right? So that means what? So that means we can set up u as sine x. We can do that. And once we do that, we then will be able to find the differentiation of du with regard to x, which is what? So what is the derivative of sine x? Is cosine x. So that means dx is equal to du over cosine x. So we good? So once we have that, what's going to happen? We're going to take whatever we have here now and substitute it back into the main problem. That's why we call it substitution problem, right? So let's go for it. So we have exponential. So sine x becomes a u. And then cosine x is there. And then dx is what? Dx is du over cosine x. Integral of that. Okay? So once we have this, what can we do? What can we do is to simplify cosine x. Most of the time when we're dealing with integration by substitution in these ways, for multiplication of them, once we get to this level, we are able to simplify something. Okay? So once we have that, we end up with integral of exponential u du. Okay? So if we continue, what then is the integral of exponential u? So the integral of exponential u is just exponential u again plus c. Are we done? No, because we have to then change the u, which is equal to sine x. So we end up with exponential sine x plus c. Ladies and gentlemen, now you are done. Thank you.